Good afternoon, all, and welcome to Python Coding and Robotics. Just a quick reminder that tomorrow's lesson will be actually cut off because we're going to be having a little function on Zoom with our two speakers, Honorable Minister Stella sorry, Ndambendi and Maria Croak. So tomorrow's lessons again will be off for tomorrow, and you'll be attending that little talks that we're going to have with your certificate presentation. On that note, don't be worried. There still will be a video tomorrow uploaded to YouTube with our lesson that we were supposed to do tomorrow. So that'll be the continuing of the game that we're supposed to create tomorrow will still be uploaded thanks to our amazing host that's doing this. All right, so going on to today's lesson. So today's lesson will be coding for gaming part 2 and a quick recap of what we did yesterday. We did the introduction to Turtle Library, that means the importance of the library and some of the functions and properties of the library itself. The first property being the screen properties that allowed us to change and manipulate the screen to different sizes, colors, and so on. Then we went on to creating a turtle on the screen and doing the manipulation of the colors, the object size, and so on again. Then I went and showed you that the screen has a Cartesian plane and the center being 0, 0. And when you want to move objects, you'll have to know where about on the screen you want to move them. So whether it's the positive X and positive Y or negative X and positive Y, depending on the screen. Then I went on and we used the turtle to draw shapes on the screen. And with the drawing the shapes in the screen, we went on to show you how to move the turtle. So we went with the forward, left, right, and back. Forward and back, remember, only moves according to which direction the turtle is facing, the object is facing. Left and right allowed us to turn the object left or right so many degrees. So we said it turned left 90 degrees. It would now turn the entire object 90 degrees. Then finally, we went on with, we don't only have to draw objects using forward, left, back, and right. We could use the circle function to make different polygons. So remember, the circle function doesn't only make circles. If we cut it down to how many sides we want, we can actually make triangles and so on. Then I showed you the different predefined shapes for the turtle. That was the arrowhead, the turtle, a square, a dot. Those were the shapes for a turtle that you could use. And from that, we learned how to put our own shape as the turtle. And I showed you this with our Team Geeks mascot. And finally, I went on with the different colors and how we can use the different colors on our screen. And I showed you that we have the red, green, and blue number system that we can use. And then we went on with the color picker, and I showed you the color picker for that. All right. Now on to today's work. All right. So moving objects on the screen. Right, so in order to move an object on the screen, we can use the following functions. The first one is the go-to function. Now, the go-to function allows the turtle to move from one position to the next. And what we do in the go-to function is we send it both the X and the Y coordinate that we want it to move to. So I'm going to open up a little Python program here quickly to show you that. Okay, Python. Right, there we have it. So I can go File, Save. And so let's save this in our lessons. Right. So again, we're working with the graphical user interface, which is the Turtle graphical user interface in this case. So we're going to be importing the turtles. And once we import the turtle, again, we'll just create our screen. I'm just going to copy out our screen from one of our previous programs, so I don't have to type the entire thing out again. So there we go. We're creating our screen. So we're creating a window. That window is going to be our screen for the turtle. And we just giving it a title, we're giving it a background color, and we're giving it a width and height for the turtle itself. Now for the turtle that we actually want to use, we can now create that. So I'm just going to create one, say, let's go with square. So I'm just going to go SQ is equal to turtle dot turtle with a capital T this time. Right. So what this does, it loads the libraries from the entire turtle into square. So what again we can do with this, we can change the shape of it. So I'm going to go shape, and I'm going to choose this time square. So if I run this, I forgot to change one more thing. We get a black screen. The reason we got a black screen because normally our colors by default for shapes is black because our screen by default is white. So I'm going to make sure that I change the color of the square. So I'm going to go SQ dot color, and I'm going to put white. All right, so there we have a screen with a square as our turtle. So now we can use the go to function to move this object. So what I'm going to do is I'm going to say, all right, go to. So I'm going to tell the square to go to, and I'm going to give it an X and a Y coordinate. Remember, our screen is broken down into a Cartesian plane. So I need to give it both an X coordinate and a Y coordinate. So I'm going to say, all right, so if I move this square somewhere along here, I'm going to give it a positive X and a positive Y. So I'm going to say, all right, let's go to 100 and 200. So what this is going to do, it's going to move our square. And that's what happened. Now our square was here. Because we said go to, our turtle said, all right, we're going to go to that coordinate, and that coordinate is 100 and 200. So that's how we would use the go to function. Okay. Next, we could also use the tx core and ty core to retrieve where the turtle is currently sitting. So if we look at this object itself, if I didn't know where it was or where it went, I can retrieve the coordinates by using x core and y core. So if I look at my code now, I can go right. The x coordinate, so x is equal to x core, and what this will do, it'll bring to me what the x coordinate is. I can also do that for y, so I can go y is y core, right, without the e. And now this would bring me the y coordinate. So what I can do with this is I can manipulate the position it is currently by just changing this values. Let's say I want to move the turtle now to the left of where it was after it went to this position. I can say the square dot go to, and I can say, okay, I have the coordinate for x. So I said it's x core. So I can say, okay, wherever you are now, if I want you to go to the left, I'm going to subtract. Remember, it has an x and a y axis. So if you want to go to the left, you're going to subtract the X values. If you want to go down, you're going to subtract the Y values. So I'm going to say, all right, let's subtract 300. And for the Y coordinates, let's subtract 250. So what this is going to do, first the turtle is going to go to position 100, 200. And because I said X core and Y core, the first thing I'm going to do is I'm going to subtract 300. So if I subtract 300 from the X, means it's moving to the left. So it'll come somewhere around there. And if I say subtract 250, it's going to come downwards. It's going to go somewhere there. So I'm expecting the values to come somewhere in this area here. But it's not going to do that currently. It's going to still stay in the same position. I'm going to try and switch the frames around because it keeps going into the other screen. Right, so there we've got the still in that position. Again, why it's still in that position? Because we told the turtle what the coordinates are going to be, but we didn't tell the turtle itself to go to that coordinates. So over here, I can say, right, now it's going to be X and Y. I don't only have to put in numbers. I can put in variables that has numbers. So now if I press save and run, sorry. Oh, okay, there's it there, and it broke because where's the reason? The reason is here. It's telling me X core is not defined. And if I look at how I used X core here, you'll know that I did it wrong because I'm saying use X core, but remember this function X core belongs to which object? It belongs to the square object. So I missed out that part there. There we have it. Right, so the object moved to the top there, and now you can see that it's moving to the bottom. That's why I'm just going to just switch around the screens for the time being. After this, all right? So there we go. So it moved up, and now that we knew that position, we told it to move minus, and there we go. It moved to that negative section. Now that's not the only way we can actually move the object. If you notice here, we have a object dot set position. Set position also moves the object to a location. And we use that just like how we use the go to function. So I can say, all right, square dot set position. What's happening to my screens? Where's that screen now? Oh, there's it. All right, so, sorry. A square dot set position. Set position. And we give it a coordinate. So I can now go and say, if I wanted to put in normal coordinates, I can do that. So I can go 300, let's go with a number that's less than 300. Let's go with 280 and a negative number, 290. Let's go 280 as well. So now if I run this, yes, I want to save. There's our icon. It moved to the top. Now it's moving to the bottom because we said go to before. And for some reason, the set position doesn't want to work here. Right, I'll have to figure out what's wrong with that just now. Probably when we do our program, I'll show you. Turtle object has no attribute, so we can't find set position. Maybe if I spelled it right, it'll work. All right, so there we go, it worked. So I'm just going to try and catch it this time. Right, so there we go. It moves to the top, moves to the bottom, moves to the right to the corner. That was minus 280 and, sorry, 280 and minus 280 is, right? So there, that's our image that moved. And if you notice, as the object was moving, there was an animation. It showed you that it moved from one position to the next. And when it moved, it drew those lines. And again, we can remove those lines by just saying that at the start, before I start moving anything, I can say, all right, I take the object and I put the pen up function. Now, if I run this, yes, I want to save. This time the object moves and it just has an animation without the actual drawing. So that's how we can use the different positions. And if you notice, it's actually by changing the different positions, we're actually making it look like an animation has been going on. Right. Going on to the next part. Moving objects using keys. Now, there's not much to do when you want to move objects by using the coordinates. It comes handy when we actually want to do something using the keystrokes or using the keys. And by doing this, that's how we create interactive games. So if we look at this, the first thing we'll need to do is to create a function to tell the turtle what to do when a key is pressed. So we're going to create functions first to tell the computer or tell the turtle what must do when that key is pressed. So for every key pressed or on key pressed or on key released, there has to be a function. If you notice, I said the definition and then the key. There has to be a definition, a function created to do that keystroke. So in the main section, we'll tell the screen to listen to the keystrokes or a mouse clicked. So before I can actually use the on key pressed or on key released functions, I have to first tell the computer, listen to the screen. If the screen is getting any input by the keyboard, that is the moment you're going to start running the functions. And if you take a closer look at this functions, I just put def, as remember our functions, we started with def, and then the keystroke. So whatever the keys are, whether it's A, W, S, D, or up, down, left, right, whatever the keys you're using is. But if you careful note this down, there's no brackets when we're using the def here. So unlike our other functions when where we had to put brackets after we call the function up, over here, we'll just call the function, but we leave out the brackets. So again, pay careful note to that part. So we're going to start off with the functions to create. So I'm going to go File, New File, and again, it went to the other screen. All right. Save. Moving using keys. And you'll notice now I started using underscores to name our files because later on when we actually want to import files, it's much easier to use that than spaces. All right, so I'm going to save that. And I'm going to start my program. What we're going to do is we're going to move our mascot that we had before. So what we're going to do is firstly, we're going to import the turtle. And we're going to, as we said, for every keystroke that we have to have a function for it. So we're going to start creating our functions first. So I'm going to have my functions. And my first function is going to be for, let's say, moving left. So move left. Again, we still have our normal functions created like this. But now we tell what we want to do when we move left. When we want to move left, that'll be the function, the main program. The main program will have our screen. So I'm just going to go again, copy out the screen part. Okay, I'm just going to copy the entire thing. I'll let pen up as well. Right, so we've got our pen up, we've got a square that we're going to be moving, and now we've got our definition ready to use. So let's look at what we have to do. So in our definition, we're going to be moving our object. And in order to move the object, the first thing we need to do is figure out which direction. So if I'm moving left, am I going to be changing the X or the Y coordinates? For those of y'all that said X, good. It means I'm going to move left. That means the X coordinate is going to change. If I move right, the X coordinate again. But if I move up or down, that's when the Y coordinate changes, all right? So moving left, so I'm going to say, okay, when it's time to move left, I'm going to take the square and I'm going to set its position, all right? So I'm going to go set set X. Let's use that function. Oh, there's a set X and set Y function that we can use to move objects as well, just in case we don't want to move the Y value, or if I just want to move X only, or if I only want to use Y only, I can use set X and that will change that X value. All right, so I'm going to say, okay, I'm going to get my X value. So I'm going to say, all right, wherever it's currently, so we'll say the square dot X current coordinate. So now this X value has the current coordinate, and I'm simply going to say, all right, I'm going to take that X coordinate, and because I'm moving left, I need to subtract. So I'm simply going to say subtract equal to, and let's move it by 5 pixels. All right, so if we move it by 5 pixels, then I can finally say X there. Now, this is the definition for moving left. So now I need to create. Oh, I'm just going to run it to make sure that there's no errors in case I spelled something wrong there. All right, still works. And you all should do that as well. As you code, run your program to see if it works. Don't type everything out and then try to solve it. So we're going to go, okay, let's start listening. So the window that we're working with must listen. And it needs to listen to any instructions that's coming to it. And when it's listening to the instructions, it must listen to specific instructions. So I'm going to say, all right, what must it listen to? It needs to listen to the window dot, let's start with the first one. It's on key. We're going to go through the all three. So when we use the on key function, what does that do? So we'll say, all right, when the on key is used, that means when you press down on a key, what must happen? What must happen when you press down? On the left key, the M left must be called. So I'm going to copy the M left. I'm going to put it down here. I'm going to say, all right. And what key must I listen to? Now you could choose the A button to move left, or you could use the left arrow. If you're using the left arrow, I'm going to put down left. You're using the up arrow, you're going to put down up. All right. So you can actually spell out the left and right, just like how you put down A for the A key. All right. So I'm going to run this. I'm going to just pull the screen over. Again, it's gone to the wrong screen. All right. So if I hold the button down, nothing happens. But if I keep pressing the button, it's actually moving to the left. So that now that the left works, I can go with the right. So I can go, okay, copy, paste. Right. But of course, this also needs to change to right here. And I need to create a function for right. Now you notice as we build this on, this is what games and so on are made of. It's just different functions doing different movements or different ideas behind different keystrokes. So this time it'll be M right. And because we're moving right, I can now go plus equal to. If I run this now, again, I said, as you do it, run the program to see if it works. And if the first one worked, the second one should work unless you made a little mistake. So now I can move left and I can move right. Next, you can do the same thing for up and down. All it means is just copying and pasting. But I'm not going to do that for the time being. I'm going to go on to the next one. The next one was, what happens when you say window dot on key press? Now you notice when we say on key, it meant that we had to keep on pressing the key. That's when we could have moved left or right. But when we say on key press, that means you're holding the button on, you're pressing the button down. When you hold the button down, what needs to happen? We're going to say move left. And I'm going to pull this up. And I'm just going to pull this over again. And now I'm going to hold down the left button. So if I hold down the left button, it's now moving continuously. So that's what the on key press does. It allows you to hold down the button and the movement will continue. Now this comes in handy when we use it with conjunction with the on key release. See, if you hold down the button, you want it to move to the left. But when you lift up the button, you don't want it to move to the left. So we can use the on key release to stop the program from moving the object. And that will be more, or I'll be able to show you more interesting with an actual program. All right, so let's start with the basics of a little game. All right, let's create one. New file. File save. Let's call this ATG. All right, so again, we're going to quickly import the turtle. And we're going to create the setup for the screen. And I'm just going to copy this over. Where is it? There's it. So screen. That's creating the screen for me. Then I can now create the shape on the screen to be my object. So let's call this ATG. All right, so I'm going to go ATG dot turtle dot turtle. And what I'm going to do in this game is, for the time being, I'm just going to create this little game that can move the object back and front by just pressing down the button once and releasing it. All right, so what we're going to do is we're going to say, all right, now that we've got the turtle, we're going to say, all right, atg.pen up. And I'm going to use a shape that is built into Python. And the reason I'm using the shape that's built into Python is because later on we can come and change this shape into the ATG mascot. So I can change it into that. And that's what we actually do. We create programs using the built-in items. And then later on, when this actual game works, we can actually change the items to look like something else. So I'm going to go circle. And let's go square. And we'll make the little chips later on to be circles. All right, so I'm going to go atg.color. and the color is going to be white. I'm going to say ATG to go to the bottom of the screen. So I'm going to say 0, and let's say since 280 worked before, I'm going to go minus 280. All right. So let's see what this looks like. Remember, as you do your work, run it and see if it works. Otherwise, you can have problems. Oh, fine. Gave me the screen, but it gave me an error after that. The error after that it gave me was big on this line here. Instead of equal to, I said equal to, and I put dots. All right, so we've got our turtle. And at this point, I'm just going to stop the sharing and reopen the sharing, the proper screen. Oh, never mind, it'll still take forever. All right, so there we go. There's the turtle at the bottom. Now we must be able to move it smoothly left and right. So we do this. By creating the positions, and I'm going to do something slightly different here. You see, I want to move the turtle as when I press left or right, I want to move it left and right. But when I release the button, I want it to stop moving. So I want a smooth movement. So we can say, all right, let's create the function. Sorry, I'm saying screen again, function. All right, so we got the function. This was our TG. So with our function, we're going to start with our movements. We're going to say, all right, define movement. So I've got the movement already done there. Just going to copy and paste it. Why go reinvent the wheel when we got it done? All right. So we set in the X and Y coordinates, and we're only going to move that left and right. Therefore, again, we've got that one part done. I'm just going to copy it, paste it. Keep it on the on key pressed. Copy this. And go right. And I'm going to change, oh, that's M right. So this should work now. No, invalid syntax, win. Oh, forgot the brackets. All right, so there we go. So we got a movement. Oh, there I made a mistake again. Copy and paste in. I forgot to change the variables. So this variable is not square, it's actually ATG. Something else is supposed to be ATG. Where's it? There. All right, so we've got a movement left and right. So we've got our ATG, we've got our mascot now that will be able to move left and right. So what I'm going to do is now, I'm going to now go on to the next part of the programming is how do we actually put down text on screen? So after we put the text on screen, we're going to make the movement for our mascot to catch some items. So first, how do we put text on screen? Save this. All right, there we go. Be nice if I could see it. All right. To write on screen, in order to write anything on the GUI, that means that little screen that we created, you'll need to create an object that belongs to the turtle, just like how we created our ATG turtle, how we created before the other turtles. We'll have to create a turtle that will be able to write on the screen. And we can do this by using the write command. Now, this pen dot just means that's the turtle that I called it. I called it a pen. Why I called it a pen was because I'm going to write, and what do you normally write with? A pen. So the turtle is called pen. So I said write. In brackets, the first thing you give it is what you want to write. After you tell it what you want to write, then normally after that is a move, whether you want to move it or not. Now this is optional, so we can leave that part out, but the next parts you have to put in. The next part is you have to tell it align equals the position you want to align it. That means left, right, center, where should it be on the screen, all right? Then you got your font, and font is equal to, open brackets, the font name. And of course, you can pull out the font names from your Microsoft Word or any other font application, even from Python. If you go and look at the different types of fonts in under code, you can take a font that's installed on your computer. If you don't have, if you want to use a special font, you'll have to actually download the font and install it before you can use it. After you give it the font name, you then tell it what the size is. And of course, that means how big or small the writing needs to be. And then after that, you tell it what type. Type means, should it be bold, italic, normal? Normally, we only select one of these, right? And of course, the other functions we can use with the pen turtle. We can say pen turtle.hide the turtle. Remember, hide turtle means you don't want to see the turtle on the screen. So we don't want to see that little small icons on the screen. And then pen.clear obviously removes the writing that the turtle made on the screen. Even if you did a drawing, if you said the atg.clear, it'll clear that writing from the screen. Now I'll come back to this little bottom part after we test out this top one. Right, so now that we've got that, I'm going to open up the ATG one more time. All right, so we're going to put some writing on the screen. And let's put a scoreboard. So we're going to create, oh, that's after the screen. Let's write some scores. All right, so firstly, we're going to create a turtle belonging to turtle. All right, so we got the pen. Now that we've got the pen, we can say, all right, let's start writing on the screen. So we're going to use the first command in order to move the writing up. Okay. All right, so let's go with pen dot color. And again, I'm going to choose white as the color. I'm going to say white pen dot write. I'm going to say, okay, score 0. Starting of the game. All right. I'm going to align the writing to the center of the screen. After aligning the writing to the center of the screen, I'm going to choose a font. And I'm going to say, all right, the font brackets, the font name, Robio, what was it? Robot, right? Roboto. Okay, Roboto. There's a writing like that. Remember, you can choose anything you want. 13, and I'm gonna have normal as my type of writing. So if I just run this currently, I'm gonna try and catch it quickly. Oh, font. 1 bracket, 2 brackets. Score IGN equal to center, comma font. Positional argument follows keyword argument. I have no idea what's going on there. Let me just copy it from one side. I already have it typed out. Just going to take out that part there. Okay, I have no idea what was the error. All right, so let's try this one more time. I'm going to run it. And it didn't run. One more time. All right, so here's the icon at the bottom. And when I release it now, it'll do the rest of the program. It says score is 0. Right, and you notice there's that little arrowhead there. That's the pen turtle. So we're going to remove that pen turtle, and we remove the pen turtle by hiding it. So we simply say pen turtle dot hide. So before we can actually write, we're going to say pen dot hide turtle. Turtle. So what this will do now, it will hide the turtle. So there we go. That little turtle is gone now. It's still on the screen, but it's just hidden. So we can just see score. But you'll notice now score is in the center of the screen. Normally when you see games, score is at the top of the screen. So we now need to move the score to the top of the screen. And remember, this pen turtle we created is a normal turtle. It's just that we're using it for writing instead of shapes. So we can actually still use the goto function with it. And we can say, all right, before you can write, I want you to go to a position. So we're going to say, all right, pen.goto. We're going to go to the top of the screen. Top of the screen is positive, just like our bottom of the screen was negative. So now if I run it, there you go. We got the turtle at the bottom. Oh, we drew a line and then it put the score. Why it drew a line? Yes, because we didn't tell the turtle, put your pen up first. So what it did was it went to the top, then it put out the score. So if we want to get rid of the line, we have to make sure that before we can move it, we say pen dot pen up. All right, so there we go, the turtle at the bottom and the scores on the top. Of course, you can make the score how big you want it to be. So that was the score at the top. Now, before I go on to the next part, which is changing the score, I'm just going to show you one more import statement. And the import statement I'm going to use is the time. The reason I'm going to use a time statement or importing time is because I want to delay the program so you can actually see the score changing. All right. So what I'm going to do is I'm going to say while true. Remember, while the while statement will only run when the condition is true. So if I say while true, that means the statement will forever run. What I want to do is I want to change the score. So I'm going to say, all right, score equals 0. And after score is equal to 0, I want to make sure that I pause my computer screen for the time being. So I'm going to use the time class. So I'm going to say time.sleep. And what time.sleep does, it puts your computer to sleep, or it puts the program specifically to sleep for how many seconds you tell it to. So I can go 0.5, and that means half a second. I can go 1, and the program will sleep for 1 second. Now I can say, all right, I can change my score. So I'm just going to copy this entire thing. Say, right, I want to increase the score. So I'm going to go score plus equals 1. So remember, games, you normally keep track of score. I can go 1, I can go 10, whatever I want to do. So I'm just going to go to 1. And I'm going to say, right, the score is no more 0. But this right statement works different from our normal statements. You can't go and put down, well, you can go and put down plus score here. But this is what it looks like. Oh, sorry, this was supposed to be string. Right, so there we go. The square is moving to the bottom to be in position. The score's on the top. And what's happening? Yes, the score is being written on top of each other every single time. So there we go. That score just changed again. So before we can print out the new score, we actually need to, yes, clear out the old score. So we'll say pen dot clear. There you go. Score 1, 2, 3, and this can keep track of scores. So now we have a little program where we understand how to code the score function. Obviously, we'll only increase the score when the, or in our case, when ATG decides to catch the chips that we use later on, the circuits that I've got, right? So when it catches the circuits, we must change the score. So now it takes us to the next part of the program. By the way, that's what I explained here, this little part here. When writing on the screen and using variables, we will be using the format function. So you see that this is slightly different to what I've got there. Why? Because if I wanted to put more than one item, I can't just put the plus sign all the time. So what I say, I put curly brackets dot format and a variable. So when we say dot format and variable, the variable will automatically go and replace the curly brackets, right? So we can use this as well instead of the plus sign, but everything else is the same. So the next part. Stop the program. We're going to create an object that can fall from the top of the screen. So I'm going to go save. Creating new programs instead of doing it all into this one program is because I want to first test if that program works before actually adding on to my working program. Otherwise, what's going to happen is eventually I'll have so much code that I won't be able to identify what's working and what's not. So here we go. We're going to create a new one. And it's on the other screen. Right. And I'm going to save this. File, save. Falling chips. All right, so we're going to go import the turtle. And I'm also going to import another function that I will be using later. So I'm going to import random now. All right, so I'm going to quickly copy out the create functions. So we're going to have screen. So we'll have window. Just going to copy it over. Oh, look at the other lines. Right, so we've got the window. We're going to create the chip that's going to be falling. So I'm going to have another turtle there with a chip. So we can go chip is equal to turtle. YT. Right. So that's going to be the chip. And we're going to quickly change the properties of the chip. I've got that already. So I'm just going to change it. All right. The reason I'm using random to go to, that means it'll choose any position on the screen on the top. So let's see if that works. All right, there we go. So that's the first time. That's the second time. And notice you can see the movement. Now, if I don't want to see the movement, what I need to do is I need to turn off the updates, and we'll get to that later, right? This is just for the time being. I just want to quickly show you how to make it fall. So we're going to create a definition to make this fall. So I'm going to go def chip fall. I'm going to say chip, forgot the colon, chip dot pen up, because I don't want to see the lines when it moves. But I, wait, already did that here. Yep, it doesn't matter then. Okay, I already did that there. No need to do it again. Let's not duplicate code. Right. What I'm going to do is I'm going to say, right, chip dot set heading. Now what set heading does, it changes the direction, and you can give it exactly how many degrees. There's 0, 90, 180, 270. So it's telling you up, down, left, or right. So exactly what heading it should look. So I'm going to say look down. So down would be 270 degrees. Remember, 90 is up, right? So now that I've got the chips looking at downwards, I can say, right, let's start dropping it. So I'm going to say, let's move the chip forward, because remember, it's looking downwards. I can say chip dot forward. And I can move it forward. And let's move it forward 5 spaces. And all I have to do now is say, okay, while this is true, I'm going to move the chip downwards. So I'm going to say chip fall. I forgot the colon. All right. And I spelled forward wrong. Where's forward again? R is missing. All right, so you can see the chip moved up to the position. You'll also see it rotate. We hit in the square, you can't see which is actually forward, but you'll see the chip rotate forward, right? And then you'll see it fall. There we go. We got a falling chip that's gonna happen. And of course, when it goes off the screen, we need to make sure that we put it back on top of the screen. So when we move forward, we also need to check if it hit the bottom. So we're gonna say, all right, if you are at the bottom, so if the the chip Y coordinate is less than 300. I got a 600 by 600 screen. So 300 should be the bottom. So when you less than 300, and it should be actually negative 300, 300's at the top, then I'm going to change your direction. I'm going to put you anywhere on the top. So now, there we go. It's fallen. And as soon as it goes past this point, it goes back to the top and starts falling. Now that going back to the top and start falling again, it looks really ridiculous, because why would you want to see where it's going to, right? You just want to catch it. So we can actually turn off that update. We can turn off the animation. And how we turn off the animation is by using a function called tracer. Tracer actually traces all our animation. So what we'll say is window dot tracer. Let's say the tracer is 0. What this does, it turns off our animation on our screen. But because we're turning off the animation on the screen, every time the chip is falling, we need to make sure that we can see it falling. So we update our screen. So we'll say window dot update. Now what this will do, it just looks like random nonsense on the screen. And the reason it looks like random nonsense on the screen, because window tracer says go to, remember, it removes our animation, but updates updating our information. And the while statement moves so fast that we can't actually see the object falling. So what we can do again, just like how in the previous work, we import the time function, and we can put our function before it can update to sleep. So we'll say time dot sleep, and I want to make it sleep for half a second. Then I made it sleep for half a second. It's moving absolutely slow. Of course, the more you go into your time, the more faster the object will move. So there we are. So now we've got a moving object. And now it just looks like as it falls on the bottom, it's going to the top, and doesn't even look like it's going to the top like before. So after this, what we're going to do is we're going to combine these two programs together. But obviously, catching one object is very silly. So we may need to do more than one object. And the good thing is we've got most of the code done. And we've learned that in our actual coding, we can use lists to store more items. So I can actually create a list for all the items. And that's why we learned list as well. So you can use it. So I can say chips is list, so equal to square brackets. So we got chips. And for every chip, we're going to do this creation. And since for every chip we're going to do this creation, we're going to use a for loop. So I'll say for I in range, and I can go range. Let's choose, let's put three, or let's put 3 items on the screen for the time being. And since all these are going to be my items, I'm going to indent it. And every time I create an item, or every time I create a chip, I store it in the list. So I'll say chips dot append, and I'll put down a chip in there. So what this will do, it'll remember one, so it's going to start off at 0, so it'll go 0, then chip 0, chip 1, chip 2. So it'll create all the chips for us. And then when I run this now, oh, invalid, it's in range, for I in range, colon's missing. All right, you can see the 3 items, but only one is falling. And the reason only one is falling is because we only told that one chip to fall. So what we need to do is we need to do this for all the chips. So we'll say for, and this is where I'm going to change it slightly, right? Before we did the range. Now this is what we can also do with the for function. We can say for chip in chips. What this does, it takes every chip that we've got in this list and it looks at it one at a time. So that's what this is going to do. It's going to look at one at the chips at a time. Why? Because I told for all the chips I have, you're going to do one at a time and you're going to do chip. I know it sounds a bit confusing, but what it's going to actually be doing, it's going to be moving all the objects. There we go. You may be saying, but that looks like it's going to be hard to catch all 3. So we can make it a bit more easier to work with. Remember, this is holding our X and Y coordinate. So I can change my random Y coordinate. I can say, okay, since I know I want to start off at 290, I can start something bigger than 290. And I can use a random range. I can go, let's go 300 and 1,000. Now this is off our screen, but the first time it'll all be in the same row, but the second time you don't see it. So it'll be falling at different intervals. So we've got falling objects. We've got our mascot that's going to catch the item left and right. We've got a scoreboard to keep track of score. And the next thing is we're going to figure out how to do the collisions and keep track of the score. So the actual game itself, the game mechanic. And that's not going to be really hard. And you'll catch that video tomorrow on YouTube. It will be uploaded. Again, there won't be any lesson tomorrow. You'll be at 2:15. You can log on to Zoom, and I'll put the link in chat for that Zoom link where you'll be getting your certificates, as well as there's a presentation by two guest speakers. I'm just going to link the link. So if you didn't get the link already, I'm just going to put it in chat. If I can find chat. All right, so that's the link for the Zoom meeting tomorrow. It's at 2:15. Please make sure you're there. And again, the video for tomorrow's lesson will be uploaded to YouTube. So the continuation of today's lesson and the actual game itself will be completed in tomorrow's lesson on YouTube. So it won't be live like today, all right? Do I have any questions from anyone? You can raise your hand and ask a question. It's fine. All right, so if there's no question, have a good afternoon, and I will see you all at the meeting tomorrow at 2:15. I'll be there, but I won't be teaching. Have a good day.